This lesson, we're going to do kind of the reverse of evaluating functions, and we're going to solve functions. So evaluating, we know x, put it in, calculate to find y. In solving functions, we know the output value y, and we're working backwards to figure out, well, what did I input x to get that y value? So let's go over some examples here. I got a couple of functions, f and g here, and we're going to practice doing some solving functions. Okay, so a typical example would be, here's my function f of x equals negative 2x plus 5. We might want to find, well, what x value gives us an output value of, let's do 23. I want to solve that out. So notice I know the output value, I know the y value, I don't know what x, it's still showing an x there. So how do I use this, how do I interpret this? Well, an easy way is to see, oh, I have f of x here, but I'm defining f of x is 23. So I can really just replace this whole equation as 23, putting that in place of f of x, equals negative 2 times some unknown number x plus 5. There you go. Do you see the x is still unknown, my input value? I still got to solve it. But if I take that x value, multiply it by negative 2 and add 5, I should get an output value of 23. And that's what we're going to solve. So we're going to solve this thing out. We're going to do some algebra. Some basic algebra here. I want to do some stuff to both sides to get x by itself. I'm going to do the opposite. I'm going to subtract 5 from both sides. Plus 5 minus 5 turns to 0. So negative 2 times x is equal to 23 minus 5 is going to be 18. Good. Good first step. Now I need to get x by itself, so I'm going to divide x times negative 2, so I'm going to divide by negative 2, so that's the opposite of multiplying. Those divide out to equal 1x, but I have to do it the same thing to the other side as well. So 18 divided by negative 2 is going to give me x equal to negative 9. So there we go. We just found the input value. So if I want to summarize it all up here, if I take my function, we just found out that negative 9 is the input value needed to get an output value of 23. If I wanted to write it in point form, if I wanted to plot a point on this function, when x is negative 9, my y value is positive 23. That's a point on my function. Okay, so there's an example of solving. We knew the output, we wanted to find the input. Let's do another one. So let's take over here, g of x. I'm going to draw a line to kind of separate here. We don't want to get all confused. All right, so now we've got g of x equals, let's just do 5. I got an output of 5. What's my input to get me there? All right, just like what we did last time, we're going to substitute 5 in place of g of x because we're told g of x equals 5. And we get the new equation, 5 equals 1/3 times x minus 7. Some of you are cringing because you see a fraction there. I love doing some fractions, and I want to give you guys as many fraction examples as I can because I know fractions can get really confusing. It's just one of those hard things that are sometimes just tricky for people to get. All right, let's figure out how to solve this though. So what input value of x is going to get me to the output value of 5? So I got to start doing some solving here. Well, right now I have 1/3 of x minus 7, but I don't want 1/3 of it. I want to get rid of it. So I'm going to multiply it by 3 because that's the opposite of taking 1/3. What's going to happen to this 1/3 times 3? I can rearrange them using the commutative property, just all multiplied. I can rearrange it like this now. We can really easily see 1/3 of 3 is just 1, and I'm left with just x minus 7. So there we go, we just undid the fractions, that's nice. But since I did the right side and multiplied it all by 3, I have to multiply the left side of the equation by 3, and it's equal to 15. So we made both sides just 3 times bigger. All right, I can take away the parentheses now because there's nothing else surrounding it. So some number minus 7 equals 15. Let's add 7 to both sides. I don't want x minus 7, I just want x. So if I add 7 to both sides, minus 7 plus 7, those are opposites. They leave just x, and x is 22. All right, so in function notation, if I want an output value of 5, I need to have an x value of 22. So in function g of 22 gives me an output value of 5. And if I want that in point form, well, that means when x is 22, y is 5, and that is a point on my function, on the graph. All right, we did some examples here, a couple examples for you of solving functions, again, using function notation, and just knowing what does that mean? What is that telling me to do?